All right, so classification, right? Here we go. Classification, this whole idea of classification, taxonomy, clandistics, my bad. It's all based on this idea that organisms can be classified based on their physical similarities. We're basing things on how they're alike. And what we're going to find is that how things get classified, it's a very subjective at times method, right? It's about of scientists coming together, arguing, agreeing on things, putting things in groups, taking things out of the group, putting them in another group. This happens all the time, and that's okay, because a big part of science is being able to make your argument, being able to make your claim, back it up with evidence. Science is done in collaboration. So the cool thing about classification is that it really exemplifies how science is a collaborative endeavor. Oh God, guys, sorry, we're just getting started here. Okay, so this all started with a man named Carolus Linnaeus, who was from Sweden, I think. But really, it started with Aristotle, right? Our man Aristotle was the first one to look at organisms and say, okay, let's start to group these. So even though Aristotle was the first one, Linnaeus was the man that put everything together in ways that we still use it today. My man Linnaeus here could use some vitamin D and maybe like a smoothie, if you know what I'm saying. It's got a little pasty skin. Okay. So he was the one that put together this idea. It was called binomial nomenclature. Two names that help to describe what each organism is, and that helps to describe what category it goes in. So when we talk about taxonomy is the science, okay? It's the science of describing and classifying these organisms, again, based on their physical similarities, okay? So he studied the anatomy. So like I said, Aristotle was one of the first people to really, that we know of. There are probably people in other countries that were doing this, and in other continents that were doing this, but we all know how history works. Aristotle was one of the first one on record. He did a lot of the first autopsies. He was the first to do a lot of dissections and record them. So he also studied anatomy, and he put things in groups, but his groups were really basic. They were like, bird, fish, animal, okay? They were pretty basic. #basic. Linnaeus was the one that dug a little bit deeper. I give the example down there of the white oak. We call it a white oak, but actually there's a scientific name, and that scientific name we owe to Carolus Linnaeus. He does, look at this. Maybe go out for a walk, my man, you know what I'm saying? If there were no cameras around and all I had was someone taking pictures of me, I would have that Mariah Carey light. I would have final say on what that painting looked like, and I would look maybe a little different. But that's me. Maybe I'm vain, okay? Maybe my man Carlos was like, paint me as you see me. Moving on. So let's talk about how he organized things. He had 7 levels. We know this. This sounds familiar, right? Kingdom, phyla, class, order, family, genus, and species, okay? So we take our little doggy dog here, our Canis lupus, okay? And he's in the Canis group, okay? Well, he's in a larger family called Canidae. He's in the order of a carnivores. So you can see these similarities, right? So you can see the similarity in body structure, okay? Then we add here fox. So that's kind of how the family structure broadens. Then you're in carnivores. So you're looking at what they eat, and what they eat, if you're looking at physical structures, you're talking about their mouths, their jaws, their teeth, okay? Mammals, warm-blooded, carry their young inside them, have live births, chordate, have a backbone. Animal, right? It can't make its own energy. It has to eat its energy it has to get its energy from somewhere else. So these are all based on similarities, and they're based on you get very, very specific, and then you broaden out. So we join the doggies right here when it comes to mammals. In fact. Okay, but here's the problem. My man Linnaeus, long time ago, doesn't account for the molecular evidence, right? He was only looking at the physical bodies. So when we talk about like DNA similarities, or how all certain living things carry out protein synthesis and those things, doesn't account for that, because it was kind of unaware of what was going on at the time. It's just based on physical similarities. Like these guys, you've got like your little doggies, you've got your wolf, I think, or this is a wolf, I don't know, someone's howling. That looks like a, what do they call it? Huskies. You got this little fox, little devious fox, all based on physical similarities. So we take what we use, because what he did, because it gives us a great foundation, but then we have to supplement that with what we know about their molecular similarities. The other limitations is that just because something is physical doesn't always mean close relationships, okay? The genetic similarities are more accurate. Take monkeys and humans, or chimpanzees and humans. Our DNA is very similar. Chimps are more similar to us than they are to, say, a dog, okay? But you might look at them and you might say, well, humans have this ability to reason. They have less body hair. They have this, they have that. So you might not necessarily class monkey and chimp together. But DNA speaking, molecularly speaking, we are more similar than that of like chimp to a dog, right? Look at that little guy. Isn't he a cutie? He's going to bite your face off. So the genetic similarities not only show how close relationships, they show close evolutionary relationships. They can show which things were more likely to share a more recent common ancestor than other things. We do share a common ancestor with every living thing, we could say, especially mammals. But we have a more common ancestor to that of the chimps than we do of dogs. And we know that because of the genetic similarities. So let's get into the scientific name part. So we do supplement, like I said, we do supplement what Linnaeus did with our understanding of these genetic similarities, and we're also still kind of uncovering these genetic similarities. So this science of taxonomy and cladestics, I'm sorry, guys. That's just the formation of a cladogram. And I'm terribly sorry, I am having a hard time speaking. Those things are all very new. So, the molecular part of it, the DNA part of it, we're constantly changing and rearranging these things. So let's talk about scientific names. We call that binomial nomenclature. Binomial, two names. By, two names. Nomenclature, for the most part, names. Naming system, right? Two names, naming system, okay? Felis catus, genus, species. Homo sapien, genus, species, okay? He prefers el gato, which means cat in Spanish. Stupid jerk. So it's a Latin phrase. It's a Latin word, and we're going to talk more about why Latin in a second. It's always written in italics to let us know that that's the scientific name, and it's always with the genus first and then the species. Okay, that's basically it. So the reason why we do use the Latin is because Latin is one of those languages that's the base of all the other Romance languages: Spanish, French. All of the languages that Italian, that when Linnaeus was in the process, was kind of like the main, the basis of all the main languages spoke in, if that makes sense. So that's why we use Latin, because it can be easily translated into all different, it was kind of like the common denominator of everybody in Europe who were part of that scientific community at the time, if that makes sense. Genus, so you're talking about physical similar species, okay? And that's capitalized. And the species is the descriptor, okay? You can have many organisms be in the same genus. But in terms of the genus species, you're talking about one specific species, okay? Always lowercase, follows genus, never written alone. You don't call humans sapien, right? We're Homo sapiens. Capital H-M-O-M-O, sapien is lowercase, always follows the species. And there's this little owl that, again, wants to claw your eyes out. Tito Elba. There you go. Don't mess with him. Mr. Elba to you. So why, again, back to why we use these names, because it gives us kind of a common language. Latin, French is also one. French more so with medicine, but you're going to find these common languages that's used across scientific disciplines across different countries, okay, and parts of the world. So it helps us communicate. Like I said, Latin was the basis of all languages that were spoken in Europe at that time, for the most part. There are exceptions, but for the most part. That's why Latin seemed like the easiest language to use when giving them official names. We see this in French too with the medical community, that we see French used quite a bit in terms of like kind of the foundation for a lot of these names. Okay, so here we go. So you're talking about similar common names, and some might have many common names. Let's talk about the roly-poly bugs, which are so gross. There's a ton of different common names, but in terms of their scientific name, it's going to be very specific. Gross. This refers to their outer shell. Vulgar. So that's kind of where we're going with this. The reason why we use these scientific names is because a common name, one part of the country might call it a roly-poly. In the South, you usually see roly-poly, and here you might see pillbug. Okay? So because the common name can change on region. The scientific name is going to stay the same. That's why we use it. So I'm sure you're super fascinated by this, but that's just basically the overview. Now, when we talk about cladograms and phylogeny, cladograms is just an illustration of how things are related by the common traits. Phylogeny and the phylogenetic trees talk more about evolution, how long it gives a layer of time to it. So phylogeny and phylogenetic trees talk more about get into the specifics of time. A cladogram is just like, hey, here's things how things are related. A phylogenetic tree takes it one step further and shows how things are related. And then cladistics, said it right, cladistics is just the science of putting together cladograms. That's what I mean by that. Hopefully all the vocab makes sense. So take some sweet, sweet notes, and we'll go over this tomorrow. All right, deuces.